Hello everyone. This video is on the Knewton Alta assignment for section 2.6 called Distance, Rate, and Time and Literal Equations. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment on your own. But, all the objectives are the same and the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. Now the assignment page, you should see the title, the mastery bar telling you how far along you've gotten. See your objectives. Looks like there are only 2 objectives for this particular assignment. Then under the current objective, right, there should be a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, right? This is for instructors only. But you will have a more instruction button. If you're ever struggling with a topic or a question, click on this button and you'll be taken to some reading or videos or both that you can study, and then you'll be working on problems related to that instruction, and you can work through the assignment that way if you wish. Alright, so the first objective I'm looking at is solve a formula for a specific variable. Alright, so we're given here an equation, a formula, an equation with multiple variables that are related in some way. 2x plus 3y equals 12, and we're asked to solve for y. Alright, so I'll write this out, and you're going to be following the same steps as you followed to solve linear equations throughout chapter 2. But you're solving for a specific variable. So the equation we're given is 2 times x plus 3 times y equals 12. And then we're solving, solve for y. So that means I want eventually y by itself equals, and then over here some expression without y. Without y. So y on one side all by itself, coefficient of 1 equals, and then some expression without y on the other side. So it's the same steps as I would follow to solve any linear equation. Notice it's just y to the first power. Alright, so this is a linear equation in y. So first, if there are any parentheses, maybe I would use the distributive property to clear parentheses, simplify both sides. If there were fractions or decimals, I might clear those as well. But then eventually I'm going to get to the point where I'm adding and subtracting. Alright, add and subtract to get all the terms that have the variable I want to solve for on one side, and all the terms without that variable on the other side. Alright, so you see this 3y is already on the left side, so I'm going to keep it there, and then subtract the 2x. Right, let's take away this 2x, make that 0, and if I'm doing it to the left side, I have to do it to the right side. Alright, so now we have on the left side 3y equals, and then over here you can write this as 12 minus 2x, or negative 2x plus 12, same thing. Very often we'll put the variable terms first and then the constants last. Alright, so now I have what I want. I have all the terms with y attached on one side, terms without y on the other, but I want 1y, not 3y. So I divide both sides by 3, right? Or you could say multiply by 1/3, right? That's the same thing. And don't forget, you're doing it to the entire side, every single term. So we have y on the left side equals, now this right side I could write in a couple ways. As this fraction I have here, where the numerator is negative 2x plus 12, and the denominator is all over 3. Or if I actually divide each term by 3, negative 2x divided by 3, that's negative 2/3 x. And then plus 12 divided by 3 is, plus 4. Both of these expressions are the same thing. They mean the same exact number. And there we go. I'm only going to type in one of these, not both of them. But we have y equals, negative 2/3 x plus 4, or y equals, negative 2x plus 12, all divided by 3. Same thing, but there the equation now is solved for y. And I'll enter one of those expressions here. I'm just going to enter that second one, negative 2/3 times x plus 4. And submit, and then after you submit an answer, right, you'll be told if you're correct or incorrect, and then be given some sort of answer explanation. Please read through the answer explanations, just to make sure you understand why something was right, why something was wrong, and hopefully you can learn from your mistakes for future questions. Okay, next. Alright, so we're still on this objective. Solve a formula, some equation with multiple variables for a specific variable. And this is very similar to what we just saw. You have a term with x plus some term with y equals a number equals 19. And we're asked again to solve for y. Get y equals some expression without y. Alright. Pardon me. Alright, so let's flip this over. The equation we're looking at is, 5 times x plus 2y equals 19. And once again, I'm asked to solve for y. Right. Pay attention to if they said solve for x, I'd be doing something different. Alright, so this 2y term is already on the left side. I'm going to keep it there. So let's take away the x term, right? Subtract 5x from both sides, right? So now on the left side I have 2 times y. And on the right side I have 19 minus 5x, or you could write it as negative 5x plus 19, same thing. And then finally, divide by 2 to get 1y, to get y alone, or multiply by a half, same thing. And don't forget, you're doing it to the entire side, every single term. So we have y on the left side equals, and I can write this as a fraction like this, negative 5x plus 19 in the numerator, all divided by 2. Or, if I actually divide each term by 2, that would be negative 5 halves times x plus 19 halves. Okay, either one of these is fine. I'll just enter this first one this time with the fraction, with a single fraction. Alright, so y equals, now since the numerator has multiple terms, I'm going to put it in parentheses. So we have a negative 5x plus 19 in the numerator divided by 2 in the denominator, and then you can go back, and now that it has the big fraction bar, you can go back up here. If you don't have to get rid of the parentheses, but if you don't like the way they look, you can get rid of them. But as long as negative 5x plus 19 is all in the numerator and 2 is in the denominator, that should be good. Great. Alright, next question. Alright, so now we're switching to the objective, use the distance, rate, and time formula. So I'll explain what that is real quick. the distance you travel for is going to be equal to the rate at which you travel. Now the rate is like speed. Right, this is going to be in miles per hour or feet per second. It's some distance unit divided by some time unit multiplied by the time you travel for. So the distance traveled equals, the rate at which you travel, or the speed, multiplied by the time. And you might see this shortened as d equals rt, right? Or r times t. Right? Distance equals rate times time. Distance equals speed times time. So for example, if you went 30 miles an hour, that'd be your rate for 4 hours. 30 miles an hour times 4 hours, hours would cancel, right? Unit cancellation. And 30 times 4 would be 120. You would have gone 120 miles. That would be your distance. So that's really it. All right, we're going to answer questions involving them now. So this first question here, Megan is taking the bus from New York City to Montreal. The distance is 380 miles, and the bus travels at a steady rate of 76 miles per hour. Okay, now this distance, rate, time formula is assuming a steady speed, a constant speed. Now I know in real life that's not going to happen. Right? You're not going. The bus will not travel 76 miles per hour the entire time in reality. But if we, take the average speed over that time, we can apply this formula. But you don't have to worry about all that. Just use the speed that's given, the rate that's given. How long will the bus ride be? All right, so again, you have this formula we're using. Now they gave us the rate, right? The speed was 76 miles per hour. Right? Miles per hour means divided by hours. Per implies division. Right? And they gave us the distance as well. Right? The distance from New York to Montreal, and this bus ride is 380 miles. And just make sure the units are consistent. If they gave my rate in miles per hour, then I would like the distance to be in miles and time to be in hours. Alright, just make sure that units stay consistent. Alright, because if they gave me this in miles per hour, and then they said the distance in feet, I'd have to change from feet to miles, or change from miles per hour to feet per hour. Right? But just make sure the units are consistent. So I pop these into the formula. So the left side is 380 miles, right? I'll just write 380. And then equals, the right side is, rate times time, 76 miles per hour. So just 76 times. And then the time, I don't know. I'll just keep calling it t. And then we solve for t to find the time, how long this bus ride took. Divide both sides by 76 and you'll get t alone. And this is a nice one. Oops, I don't know why I wrote 75. But 76 goes into 385 times. So you have t equals 5. And then the units on this, remember, rate was given in miles per hour. So the time units I would want to be in hours. This should be in hours. And there it is. Right? 380 divided by 76, 5 hours. Right, 76 miles an hour for 5 hours, that's 380 miles. And most of these should be that quick, that simple. Now they already have the word hours there, so I just need to put the number, the value of t, 5. Alright. Now I'm sorry, I used capital letters. They're using lowercase letters. It doesn't matter. As long as you understand what means distance, what means the rate, which one's the speed, and what means time. Okay. Next. Alright, sticking with the same objective. So here Sean took the bus from Seattle to Boise, a distance of 506 miles. If the trip took 7 2/3 hours, which I will definitely change to an improper fraction. I personally do not care for mixed numbers like this. What was the speed of the bus? What's the rate? And notice it's in miles per hour, the answer. So, the distance was in miles, the time was in hours. So the speed, the rate, should be in miles per hour. Alright, and again, just filling in parts of that formula and solving for the missing piece. So I'll write the formula again, right? It's just the distance equals the rate of speed times the time. And we're told the distance between Seattle and Boise is 506 miles. We're told the rate, no we're not. No we're not, that's what we're trying to solve for, sorry. And then the time, now they told us the time it took to take that trip was 7 2/3 hours. Right, but I'm going to call that, remember how to change a mixed number to an improper fraction. Multiply the whole number by the denominator and then add the numerator. That becomes the numerator of the improper fraction. 21 plus 2 is 23, and then the denominator stays the denominator, right? That's 23/3 hours. So I'm going to use that instead. Right, 23/3 is the same as 7 2/3. Alright, and then I solve for r, solve for the rate. And if this is miles, this is hours. Right, if I divide, I'll get miles per hour. Alright, now, instead of dividing by a fraction, right, you may have seen this in previous videos. Remember, division is just multiplication by the reciprocal. So instead of writing divided by 23/3, I write times 3/23. Alright, this is the reciprocal of 23/3. So times 3/23. Right. And then we'll simplify things. Right, now again, the whole reason I'm doing this is so that these are gone, right? 23's cancel, 3's cancel. You have r equals, and I'll switch sides, put r on the left. Let's see, how many times is 23 going to 506? I know 23 times 10 is 230, so times 20 would be 460, and then plus another 46, so 22. 23 goes into 506 22 times. Yeah. And then 3 times 22 is left over. That would be 66. And again, this is in miles per hour. Miles divided by hours, or mph, whatever. And that's what they want, right? The 66. So this trip, the bus traveled on average 66 miles per hour. Great. And again, please read through the answer explanations. Alright, still in this objective. So Socorro, or I don't know how to pronounce that, I apologize, drove for 4 5/6 hours, which again I will change this to an improper fraction, but there's the time at 60 miles per hour. That's a speed, that's the rate of speed, the rate. What distance did she travel? So I'll just stick to the same piece of paper here. Just go below here. We don't know, we're just solving for the distance. Well, the nice thing about this formula is that distance is already solved for. D is already alone. the rate of speed is 60 miles per hour times the time, and again the time is given in hours. It's 4 5/6 hours, which again I'm going to change into an improper fraction. 4 times 6 is 24, plus 5 is 29, so this is 29/6 hours. And then we just simply multiply to get the distance in miles. Miles times miles per hour. I'm sorry, miles per hour times hours. The hours will cancel, you'll be left with miles, right? The distance in miles. Now 6 goes into 60 10 times. So really I'm just left with 10 times 29, or 290. Right? So the distance traveled was 290 in miles, right? The units were in miles there. And they already have the word miles for us, so we just need to enter the number, right? 290. And there you go. Alright. Then it looks like, wow, 4 of these in a row. Okay. So here, another, we have the rate, 60 miles per hour. We have the time, 7.5 hours. So what distance was traveled? Just multiply these. Now, 60 times, now we could have also done this, 60 times 7.5 would be 60 times 7 plus 60 times a half. So that's 420, and then half of 60 is 30, that's 450 miles. And I'll leave it to you to do the multiplication on paper if you want, but this would be 450 miles traveled. Pretty simple if you know the rate and the time. Alright, now we should have just 2 more of those formula questions. There, solve a formula for a specific variable. Alright, so solve I equals P times R times T. This is what they call the simple interest formula. Principal times rate times time, or present value times rate times time equals interest. You don't really have to know all that, just this does come up in finance. Solve it for P when I equals 5,480, R equals 0.04, or 4 hundredths, and T equals 7. And you're asked to round your answer to 2 decimal places. So we might be using a calculator here, but let me start off with that formula first. Alright, the formula is, I equals P times R times T. And say before I even put in any of the numbers, what if I was asked to solve this for P like they're asking? So I want to get P alone, this capital P. Right, I want P equals, and then again some expression without P in it. That's what we want. Now, if you want P alone, right, all the terms, all the products with P in it are on the right side. There's just this one term, PRT. And then all the terms that don't have P, I, right, is on the other side. So that's good. And then we want to get P alone. Now remember, this is P times RT. So I just divide both sides by RT. So P equals, I divided by the product of R and T. That's it. And now I just punch in the numbers that we were given. Alright, the principal, or P equals, now they told us I was 5,480. So I have 5,480 in the numerator. Then R was 0.04, and t was 7. And we're asked to round this right to the nearest hundredth, 2 decimal places. So this is 5,480, right, divided by, and then this is 4 hundredths times 7, that'd be 28 hundredths, right, 0.28. And then I can just enter this into a calculator if I wish. I mean, you can do this by hand as well. Multiply the numerator and denominator by 100 to make it 548,000 divided by 28, and then do long division until you get to the the 3rd decimal place, and then you can round to the 2nd decimal place. But I'm just going to go to a calculator. All right, this is a free online calculator at desmos.com, and you can just do some calculations off to the side here. 5,480 divided by 0.28. Yeah, so that's 19,571.428. So that would round to 0.43, right? The nearest hundredth, round to 2 decimal places. Yeah, so this is approximately 19,571.43, and this is what we'll be entering for the value of p. Okay, great. Back to the assignment. 19,571.43. Wonderful. Okay, now they put it into the formula initially and then divide, but still, whatever r times t is, that was that 0.28, you divide by that, right? Which is what I did with all the letters. Okay, and we should have just one more of these based on my progress. Alright, so this here, p equals 2l plus 2w, you may recognize this one as the perimeter of a rectangle, right? Twice the length plus twice the width equals the perimeter. But again, you don't need to know that. Just know that you have a formula here, an equation with multiple letters in it, multiple variables, and you're asked to solve for one of them. Get one of them alone. So I want L equals, like they have here, and then some expression without L on the other side. And this is really no different than some of the formulas we saw earlier with x and y. Right? So we have p equals 2l plus 2w, and we're asked to solve for L. So first I'm going to move terms that don't have L in it to one side and terms with L in it on the other. This 2L, this is the only term that has L in it. It's on the right side, so I'll keep it there. And then take away the 2w term. Alright, so now on the left side, I have p minus 2w equals, and on the right side, the 2w is gone. I have just the 2 times L. And now, to get L alone, I would just simply divide by 2. Remember, you divide everything by 2. This entire left side, all the terms by 2. So the 2's cancel here. Now I'm going to switch sides, so I'm going to put L on the left now. Equals, and then you can write this fraction the way it is, p minus 2w in the numerator, all that divided by 2. Or, as I've been doing in previous problems, actually divide each of these by 2. You have p divided by 2, or 1/2 p. You can write p divided by 2 or half p like that. Minus, and then 2w divided by 2 would just be w. Alright, so either one of these is fine. Again, I'm not entering both of them. They're both equivalent, but just one of these expressions should be good. Yeah, so this is saying that the length of a rectangle is half the perimeter minus the width. Or the perimeter minus twice the width, and then divide all that by 2. And I'll enter that second expression. Alright, so L equals, let's go get in that box here. So 1/2 times p minus W. And again, make sure you're putting in the correct, these are capital P, capital W. Make sure you're putting in the correct letters and that they're capitalized, right? They got, because a capital P and a lowercase p could represent two different things. So just be careful that you're entering the correct variables. Alright, wonderful. Yeah, so see they left it as p divided by 2. That's the same thing as 1/2 times p, right? Dividing by 2 is multiplying by a half. Alright, and again, please read through your answer explanations. And that should be it for this preview version of this assignment. And like I said at the top of the video, just understand that the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure is similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. And thank you very much for watching.